uniform wires of the same material are vibrating under the same tension, if the first overtone of the first wire is equal to the second overtone of the second wire, and the radius of the first wire is twice the radius of the second wire, then the ratio of the length of the first wire to the second wire. It's a very, very simple problem. Just we have to start with the formula for the fundamental frequency of the wire, right? So let's find the solution. We would start with the fundamental frequency of the wire. The fundamental frequency of the wire can be mentioned as F is 1 upon 2 L1 square root of T upon M. Here M is nothing but the mass per unit length. But now we need to connect this frequency with the radius. So we can't use this formula as such. We need to convert this mass per unit length in terms of density so that I would be able to connect it with the radius. So how to do it? I know the formula in terms of radius also. So I can write this mass per unit length in terms of radius as pi r square into rho, right? So this r square is inside the square root, so I can take it out of the square root. So this would become 2 L1 R1 square root of T upon pi into rho. Okay, this is the fundamental frequency of the wire. Now let's go for the first overtone. So the first overtone of the first wire, I'm going to mention this as F1. F1 is nothing but 2F as we know. Substitute this value of F as 1 upon 2 L1 R1 into square root of T by pi rho. So this would become 2 upon 2 L1 R1 square root of T upon pi rho, which is nothing but 1 upon L1 R1 square root of T upon pi rho. Okay. In the numerical, it's given the first overtone of the first wire is equal to the second overtone of the second wire. So let's go to the second overtone of the second wire. So the second overtone of the second wire, let's mention as to be F2, which is nothing but 3F. I already know the value of F. So if I substitute this, I would get 3 upon 2 L2 R2 into square root of T upon pi rho. Okay. And the first overtone of the first wire is actually equal to the second overtone of the second wire. That means F1 is equal to F2. So 1 upon L1 R1 square root of T by pi rho is equal to 1 upon L2 R2 into square root of T upon pi rho. 1 R1 square root of T by pi rho is equal to 1 upon L2 R2 into square root of T upon pi rho. Sorry, this is actually 3 by 2, right? We have 3 by 2 L2 R2 square root of T pi rho here. So this T upon pi rho is common, so it would get cancelled. So I would get 1 upon L1 R1, which is equal to 3 by 2 L2 R2, correct? So now this would become 3 L1 R1, which is equal to 2 L2 R2. It has been also mentioned that R1 is equal to 2R2. So let's substitute this here. So now this would become L1 by L2 is nothing but 2 by 3 into R2 by R1, where R1 I am going to substitute this 2R2. So this 2 would get cancelled, R2 would get cancelled. So the ratio of the length L1 by L2 is actually 1 by 3. So the correct option is actually 1 by 3. I hope this is clear. We'll move to the next one. The ratio of